Students, during last lecture, we discussed about the difference between the process and threads. Okay, you know that the process is a instance. It's the executing instance of an application. Any application, in the application, which part is currently executed. Okay, so that is called the executing instance of that application. Okay, so that is called a process, or you can say process is a program on execution also. Okay. Then what is thread? Thread is a path of execution within a process. Within a process, to execute a particular process, there could be many paths. There could be many, for example, you want to print. Okay, you want to print a document, you will simply give the print command. But that print command will create many threads. One thread will store the file name which you are printing in the print spooler. Okay, and another thread will see that whichever content in that file, if it is not required, if one file may 5 pages are there, all the 5 pages you will give for print. No. So 1 or 2 pages if you give, it will just monitor that which are the pages you are giving for print. Another thread will allocate memory to store the print data, okay, in a main memory. Like this, many threads will be created. Okay, so process is single process, but inside the process there are many execution paths. Okay, those execution paths are called in a process. Within a process, there are many execution paths. Those execution paths are called threads. Okay. Very importantly, you have to note that process will have its own address space, thread will not. Because thread is created inside the process, no? So process ka the thread will share threads in a single process. Threads in single process will share the address space of its own process. Okay, so each and every thread will not have its own address space. Okay, it will share the address space of the process. Okay, this is very importantly you have to note. Okay, now what is multi-threading? When we are saying actually the threads, if any process more than one number of threads is there, that is called, that will perform the task of multi-threading. Okay, see, if any process, if the threading is there, threading is embedded, then definitely it will have more than one number of threads. It will not have only one thread. Okay. If it has only one thread, that is there is no need of threading. No, that is being in a single process, it can do. Okay. So threads means always it will be more than one number of threads. Okay. Now you may ask, ma'am, little confusing because there are multiprocessing. Now you are saying multi-threading. Can you differentiate the difference between multiprocessing and multi-threading by giving real-time example? Okay. Multiprocessing. For example, in your computer, you are starting multiple applications. 3 applications you are starting. Each and every applications are different applications. Those applications are different applications. Okay. So 3 different applications you started. Okay. Now this you can see, you can say multiprocessing. Okay. Because multiple process, when you open 3 different applications, definitely 3 different process will be created. Please understand. So here it is called multiprocessing. Okay. But multi-threading in a single application, underline, in a single application, there are more than one number of process more than one number of tasks are enabled in a single process. Sorry, in a single application. Okay. In a single application, that needs more than one number of what? Tasks should be performed, should be completed at the same time, simultaneously. There only the threads. Okay. This is the example, good example for multi-threading. This is very good example for multi-threading because multi-threading means single application, right? Here in this example, we are seeing only one application as a word processor, not multiple applications. Only one application. Okay. So in one application, what we are doing, assume that this is a three-threaded, three-threaded program. Okay, this word application is a three-threaded program. Okay, one thread, what it will do, it will interact with the user. Interact with the user means what? It will interact with the keyboard. Why it has to interact with the keyboard? Because it has to listen, monitor if any input is given by the user or not. So for example, user is typing A, D, E, F. That should be monitored by this particular thread. So this thread is connected with the input device. Okay. So this thread will interact the user. Why user? Because user only will type the input through the keyboard, no? Okay. So one thread will interact with the user. Okay. What the another thread will do, this thread in the same word processor, what you are doing, you are giving some input, okay? Those input, those line of text or string, something like that, whatever you type, that should be positioned properly where you are aiming to store in the document, which is called editing simply. Okay. So in the same word document, you are editing. The content is going and stored, located in a appropriate place. Okay. That is handled by the middle thread. Okay. Editing with the opened word document will be handled by another thread. What actually the third thread is doing, assume that this application has auto save option. Okay. Automatically, whenever the typing happen, in particular prefixed time interval, it is keep on saving the data. Saving the data, the file means what? Word if you type any content, where it will be stored? In the disk only, no? So it keep on taking the backup of the content. Okay, whatever you type. So these are three threads. Now these three threads are working together. Actually, the user, what he is doing, he is giving input. Only he is giving input. Whatever he is giving, so what input, what keyboard may, which number he is pressing. Okay, what are the keys here he is pressing? That should be observed by one thread. Another thread will put the entered content in the document. Okay, in the Word file. The third thread will keep on save the document in periodically, in particular time interval. So this is very good example. That's why this I included in the PPT. Okay, this is a very good example for multi-threading. Okay, here you should not confuse with the multiprocessing because there is no more than one application, only single application. What is that? Word processing. Okay. Okay. So when we are, the thread is little challenging one. That means there are three arguments in your textbook they have given. There are three reasons or three arguments for having threads. Okay, threads are mini processes within a process. Remember, it's the execution path of a process. It is a mini process within a big process. So maximum whatever the process will do, no, everything the thread can also do. But a thread is a lightweight process because there are some very few tasks will not be done by the thread as being in thread. Okay. For that, it has to be process. For example, execution. Execution cannot be handled by a single thread. It should be handled by a process. Okay. So that we are saying that thread is a lightweight process. Okay. That means when we are saying process is a heavyweight that means it can do many complex tasks, but at the same time, thread will not. Thread will not do many complex tasks. Okay. So that is also a difference between the thread and process. Process only can perform the execution. The word execution completely related to processor, no? So thread cannot cannot perform the task called execution, but a process can perform execution. Okay. So I may ask differentiate between thread and process also. Okay. So you can write about lightweight process, heavyweight process. Execution cannot be done by the thread. Okay. Thread will share the address space of the process, but more than one number of processes will not share a single address space. All these are what? Difference between process and thread. In your textbook, there are 3 reasons they have given why, if any of the application needs thread. Why without threading, multi-threading, can't we create application? Yes, of course, we can create the application because after invented the concept threading only, the applications are upgraded with the threading concepts. Because threading will increase the speed of the execution. That is very big advantage of threading. Okay. What are those 3 arguments or what are those 3 reasons which will justify that we need thread? We need threads. Okay. First one, in many of the application, multiple activities should run at the same time. In many of the applications, in a single application, more than one number of activities run at the same time. So, if this can be done even without threading also, but how it will be done? Process will be created. Okay, if any other task in the same application should be performed, this application will be it will be passed sometime. We can call clearly in a technical term, interrupt will be created. Okay. Interrupt will be created and the ongoing application should be passed. For example, simple example, now if no threading is there in a single application, when you give input simultaneously, the data will not be located. Okay. When you give input, it will take some time. After you give input, the data will be stored in the in the document. Okay. And simultaneously saving and editing cannot be happen. Okay. When you click save, it will take some time to save the document. But at the same time, while you are saving the document, you can't do any other task with this application. Okay. That means what actually happening? Each and every task will be interrupted by other task. For example, when any input comes, no, this too will be interrupted. Okay. And it will be stopped. Okay. So when you are saving the file, the other two will be stopped. Okay. Simultaneously, all will not happen together. Okay. Because there was no multi-threading. Okay. So first reason is why we need multi-threading, why we need threads, because multiple activities should be, many times multiple activities should be run at the same time in an application. Okay. If it is not there, also we can perform multiple operations in a single application. But what will happen? There are many things. It will take time. First, interrupt will be enabled. Interrupt should go and interrupt the task which you suppose you are giving the input. Okay. So now this input will interrupt other task. Okay. So that means other task will be stopped. And then related to its timers should be switched. So there are many other related tasks. When we are seeing, we may think only interrupt will be created. But when interrupt is created, simultaneously there are other interrupt related tasks which should also be completed. Okay. So implementation of the thread is very simple because threads in one process share a common address space. Okay. Because easily you can perform the multitasking in a single application. Okay. The reason is there is no switching here. All these three threads, all these three threads will share a single address space, single memory. Okay. So that is the first reason. Second reason is as I said, threads are lightweight processes. Okay, they are very faster to create, and it can be easily destroyed. Okay, uh, so if you consider approximately creating threads, goes 10 to 100 times faster than creating a process. Only creating a process and creating threads, if you compare, 10 to 100 times depending on the processor speed. Okay, different processor we will use in a different computer. That's why this range 10 to 100 times faster than creating process. Okay, creating threads are 10 to 100 times faster than creating a process. Then you can imagine the speed of the threads. Okay. One more very important thing here you have to understand, which is the third point, third reason why we want thread. If you think in a multi-processing system, only the threads are very useful. Okay, threads are very useful in a multi-processing system, because suppose assume that there are many processes. There are many tasks, we can say. There are many tasks. All the tasks are IO bound. All the tasks are IO bound. IO bound means what? Input output dependent. Okay, depend on the input output device. See, there are two category of task. One set of tasks are related to CPU, that means processor bound. Some tasks are IO bound. Okay. Assume that all the processes or all the tasks which are simultaneously should be executed are IO bound, input output bound. Then thread will not be useful. The use of the thread is not actually very good there in that application. Okay. Thread should be completely efficiently used. Then the application should be CPU bound. Okay, that means the activities need CPU. Then only what? It will be threads will be very useful. See, why? Because processor, there is a single processor. Okay, so the threads when the multiple tasks are getting performed, the IO, if suppose more number of processors are IO bound, there are one or two input devices connected with the system. There may be two output devices connected with the system. So each and every task can take its own input or output device. Okay, so there is no simultaneous processing over there. Okay, so wherever the tasks are processor bound, there only we can see the actual use of the threads. Okay, so these are the three reasons where actually the threads are very useful. Okay, we can keep this as arguments also. Okay, the first one, in one application, multiple tasks should be performed simultaneously. So we need a thread. Okay. Second argument, those processes should also be done quickly. Okay. That's why we need thread. How it will be quickly? Because threads are lightweight process. It will share a common memory. So switching is very easy. Quickly it can happen. So that is why the second reason is what? The multiple tasks using threads will happen very quickly than multiple processes. Okay. So we need thread. Third point is the actual argument. Okay. Third point says that wherever in a multiprocessing system, the processes are processor bound. Maximum of the processes are processor bound. There only you can get the gain of the multi-thread. Please understand, if multi-threading will work very fastly, parallelly with the processor. Okay. But when IO devices actually IO processes, without the help of the processor, it can be executed. Okay, so if more number of processes are IO bound, it will not considerably reduce the processing time because of threads. Okay, but whereas the processor, many of the tasks are processor bound, then you will get the quicker, faster access. Okay, you can complete you can speed up your processor. Okay, so that is the third argument. Okay. So in your book, there are many examples they have given for the multi-threading. Okay, but one of the example I just want to say, that is in web server, how the multi-threading is used, which very simple. There are two threads, two category of threads here in a web server. One is called dispatcher thread. Another one is called worker thread and dispatcher thread. Okay, so these are two category of threads in a current web server, web-based applications. Okay, so now look at this. This is just an algorithm. Okay, what is this algorithm says? While loop true, then what will happen? Get next request. Okay, this is the dispatcher. This is the dispatcher threads algorithm. Dispatcher thread, when the condition true, any condition, whatever, that's why here simply given true. Okay, true. That means if you get any request is not what here. Here you have to think the situation. Using the browser, you are requesting some pages. Okay. Web server is searching and giving you the requested page. Okay, that scenario here you have to remember. Simply, you are opening the browser, not only you. Like many people, they will open the same browser. Okay, for example, you are opening Google Chrome. You are typing that something in operating system, scheduling you want to study. Okay, so you want to know. So you are typing first come first serve algorithm in scheduling. Okay, so this is the request which you send. Okay, now when you send the request, the server will catch the request and it will search the content what you typed is there in the web server or not. If it is there, it will what? It will give back that to the browser. Then the answer you will see on your browser. Okay, this is what usually happens. Okay, so internally there are two threads which are working to complete this task. One is called dispatcher, another is called worker thread. Okay, the first algorithm here, this will be executed by the dispatcher thread. When the condition true, I will tell what is this. Okay, get next request. Means the dispatcher thread will be ready to take the next request, because only one request you will not type. If you open the browser, what? One after another, keep on, you will type and search something. No, okay. So the dispatcher thread will be ready to catch the request. Okay, get next request. That needs some memory. Okay, to store the dispatcher thread, that needs your request related information. To store that, it needs some buffer. That's why there is a parameter called buffer here. Okay, and then hand off. If the dispatcher threads only works, it will keep on look at anything is typed in address bar or Google. Okay, if it typed, it will catch that. It will just very simply give to the worker thread. That's it. Okay, again it will keep on look at the request. Okay, so while true means what? The dispatcher thread exists. It will get next request. It will take the next request and it will store in the data. And then after it received the request and store the respective data, it will hand off that particular request related information to the worker thread. So hand off work means what? It will just give the work to the worker thread. Whatever worker thread will do, it will execute this algorithm. While true, wait for work. So this will also, to get some work from the dispatcher thread, it will wait. Okay. Look for page in cache. So that's what here it saved the data. Whatever request it received, that will be stored in the buffer. So it will look at the buffer. Even if it receives any work. See, first worker thread waiting for work. Okay. That time also it will look into the buffer. Okay, if in buffer any data has been written by the dispatcher thread, then immediately it will understand that okay, work has come. Okay, so look for page in a cache. Look for page in a cache, and then here it is using two parameters: buffer and page. Okay, wait, I'll tell you. Okay, if page not in cache, that means it will first, the related page, it will check in a cache memory. Okay. Because if suppose that page is frequently accessed by the user, it will be stored in the, stored as a cookie, in the temporary memory cache. So it will first look into the cache. Okay. If page not in cache, then it will read the data from the disk. Okay, and then return the page to the browser. Okay, so this is the work of the worker thread. This is the work of the dispatcher. Okay. So now what dispatcher thread will do while true? Okay, when it is activated, then get next request. It will get the request and will store the data in the buffer. And with the buffer, it will hand off the work to the worker thread. Okay. In the worker thread side, what it will do? 24/7, it will not get work. Okay. So it will also start the work with expecting whether it got work or not. Okay. Once it received the work, okay, once it received the work, now what is the worker thread's work? It has to give the response, it has to give the answer for the request. Okay, so it will look to the corresponding page, requested page is there in the cache. Okay, if it is there, it will give. Otherwise, if it is not, then it will read page from the disk. Okay, so if for the page in the cache, suppose this is true, then directly it will, these two lines will not be executed. It will come here, return the page. Okay. So now if the requested page is there in the cache memory, then quickly the response will go. Okay, to the receiver. If it is not there, then it will take some time to search the corresponding page and find in the particular server. The server data will be there in a disk. Okay, so that will take some time, but it will search and give the response. Okay, is this clear? This algorithm is clear. So behind, whenever you just to open and search anything in the web, this is what happened. Two threads. There are many more threads, but for simplicity, they have given only two threads. Okay, dispatcher thread and worker thread. Dispatcher thread will just see whether any request has come from the user through the browser. Okay, if it comes, it will just hand over the information, requested information to the worker thread. Then worker thread, upon receiving the data, it will look at if any request comes in the web, the result will be web page, right? So the worker thread will look into the cache whether the requested page is there or not. If it is there, very simple, it will immediately return the page to the requested browser. If not, it will again look inside the web server page, which will be there in the disk, and it will find the page. It will return the page. After it return the page, you will get to see the response in your browser. Okay. This will happen everywhere. For example, Google, when you open the Gmail, you're typing gmail.com. Okay. So that is one request. That request also will be first catched by the dispatcher, and then it will be given to the worker thread, and then worker thread maximum Gmail and all will be there in a cache. Okay, because which are frequently used pages. So from the cache, the Gmail page, the home page of the Gmail will be displayed to you. Okay, you only typed gmail.com, so it will be displayed to you. Then what you will do within the Gmail, again you will click something. For example, you are entering username and password. Okay, so that username and password data will be catched by the dispatcher thread, will be given to the worker thread. Worker thread will go and verify whether the data is correct or not in the memory. If it is right, it will give us a page. If it is not right, it will different page, error page it will give. Whatever you request, either error page or the actual page will be written by the worker thread. This way, multi-threading will work. Okay. If the multi-threading is not there here, what will happen? If multi-threading is not there here, what will happen? A process will be created as soon as you requested. That process will see whether any request is coming. If the request comes, it has to make the context switching. Okay, and then it has to go to the cache memory, and then in the cache memory it has to check. So every time the pointers and the memory, everything will be updated when it is moving. So we are going to enter, and then the same process will go and see the disk, and then if it is there, the page will be returned. After that, again context switching. Here we are saying simply context switching, but during the context switching there are many data to be changed, including the timers, and then it will come here. So switching, one process switching between one task to another task will take more time. Instead of that, there are two threads, two different, it is like two different execution paths. Okay, each will do its work without interfering with each other. Okay, so the task will get over quickly. Clear, students?
Yes, ma'am.
Okay. Now, before seeing the race condition, there are something I have to explain to you. We will see what is inter-process communication. Inter-process communication. We saw about process, threads, examples and all. Now we simply called the inter-process communication as IPC. IPC denotes inter-process communication.